Hi, in this video we'll talk about solving exponential equations. Okay, first thing we want to do is isolate our e to the x portion, and then we're going to apply inverse functions, and we know the inverse of e is the natural log, so we're going to apply inverse functions to get our variable out of the exponent portion. So the first thing I want to do is isolate the e to the x, and currently I'm multiplying by 4, so I'm going to divide each side by 4. I get e to the x equals 83 over 4. Now notice I've isolated my e to the 4, and so I want to apply inverse function to get the exponent out of here. I know the inverse of e is the natural log, so I'm going to take the natural log of this. And now remember, whatever you do on one side of the equal sign, you have to do on the other. So I have to take the natural log of the other side. Natural log of e to the x, essentially the natural log and e go away and just leave you x. Again, that's definite, that's because they're inverse functions. And over here I'm left with natural log of 83 over 4. And that's your answer. You can convert this to a decimal if you want. It's 3.033. Okay, let's do another example here. Again, I know it's not e to the x, but it's e to the minus 4x, so that's the part I want to isolate. Currently multiplying by 200, so I'm going to divide each side by 200. Over here I'm left with e to the minus 4x, and over here I'm left with 15 over 200, which I can simplify to 3 over 40. And now I'm going to take the natural log of each side so that I can get my variable x out of the exponent. Natural log e essentially go away and leave me minus 4x, again because of inverse function. And over here I'm left with natural log of 3 over 40. For my final step here to isolate x, I'm going to divide each side by negative 4. And I get that x is equal to natural log 3 over 40 divided by negative 4. And I can simplify that to be x equal to 0.648. In my final example, I can actually work this two ways. I worked it one way, and then I looked at the solution, and they had worked it a totally different way. The way I chose to work it is by applying natural logs, or by applying logs. So I took the natural log of each side, okay, as first, and then I applied my rules of natural logs. So this left side became natural log 500 minus natural log 1 minus natural log e to the 2x. Recall that we can separate, recall that subtraction goes hand in hand with division, which is why these two in the bottom became negatives. Okay? And now I've got that equal to natural log 2. Remember, whatever I do on one side, I have to do the other. Because I took the natural log of the left-hand side, I had to take the natural log over here. And so one thing that occurs to me right away is that the natural log of 1 is 0, so that will go away. Okay? And I'm left with natural log 500 minus, okay, and again, my inverse function applied. Natural log and e cancels out, so I'm left with minus 2x equals natural log 2. I can subtract natural log 500 each side, and I'm left with minus 2x equals natural log 2 minus natural log 500. And for my last step, again, divide each side by negative 2. And I would end up with x equal to natural log of 2 minus natural log of 500. But again, laws of exponents apply, or properties of logs apply, and this is 2 divided by 500. So my numerator simply becomes the natural log of, let's see, 1 over 250, right, divided by negative 2. And if I simplify that, I get x is equal to x is equal to 2.76. Please note that I copied down the wrong problem. In the book, number 10 actually is 5,000, so keep that in mind. All right, now the way the book did it over here is they did not use natural logs or properties of logs. Instead, they did cross multiplication, and said this is 2 over 1. So on my left-hand side, I end up with, let's see. Okay, so on my left-hand side, I end up with 500 times 1, which would just be 500. And over here, I end up with, my 2 would come down here, okay? And over here, I'd be left with 1 plus e to the 2x. To see how that's working, perhaps we should rewrite it, okay? And I'm going to go over here. Sorry for the mess, okay? So it's 500, 1 plus e to the 2x equals 2 over 1. So I do the cross multiplication, which means I take 500 times 1. That's where the 500 is ending up here. And then I take 2 times this, but then I divide that by 2. So the 2 ends up over here, and the 1 plus e to the 2x ends up over there. Okay, so now on this side, I'm left with 250, and on this side, 1 plus e to the 2x. I can subtract 1 each side. You end up with 249 equals e to the 2x. And now at this point, I'm ready to apply my natural logs. Okay, so I can take the natural log of this side and the natural log of this side. So I end up with the natural log of 249 equal to 2x, because natural log e, inverse functions. And now to get x, I simply divide each side by 2. So again, I end up with x equal to natural log of 249 divided by 2, which if I use the calculator, again, gives me x equals 2.76. So my purpose of this last example is just to show you that there is more than one way to solve these, and you should end up with the same answer regardless of which rules you apply.